Welcome to Study Loop.
In this problem, we want to predict the magnitude and inclination of the Earth's magnetic field at the geomagnetic equator for part A and B. So we have for part A, geomagnetic equator means lambda m is equal to 0. So the field is just mu0 mu divided by 4 pi r cubed. And you can put values here. This is 4 pi times 10 to the minus 7 times 8.00 times 10 to the 22 divided by 4 pi, and the radius of the Earth 6.37 times 10 to the 6, and this gives a magnetic field of 3.10 times 10 to the minus 5 Tesla. And for part B, you want the angle, so the angle phi I is equal to inverse tangent of 2 times the tangent of lambda m. Lambda m is 0, so this is 0, and inverse of tangent of 0 is 0, so this gives 0 degrees as expected. For part C and D, you want to know at the latitude of 60 degrees. So for C, we have lambda m is equal to 60 degrees. Then B is equal to mu0 mu divided by 4 pi r cubed square root of 1 plus 3 sine square of lambda m. This number here is what we calculated before, so this is 3.1 times 10 to the minus 5 times the square root of 1 plus 3 sine square of 60 degrees, and this gives a magnetic field of 5.59 times 10 to the minus 5 Tesla. And now for the angle, for part D, the angle phi I is inverse tangent of 2 times the tangent of 60 degrees, and this is 73.9 degrees. Finally, you want to know the magnitude and inclination at the north geometric pole. In this situation, lambda m is 90 degrees, so E lambda m is equal to 90 degrees. So now we have B equal mu0 mu. This is the same expression as before, 4 pi r cubed square root of 1 plus 3 sine square of lambda m. Now this term will be 1, so this is 3.1 times 10 to the minus 5 times square root of 4. This is 2, and then this gives us 6.2 times 10 to the minus 5. And finally, we have for F, the angle phi I is tangent of minus 1 times 2 times the tangent of 90 degrees, and this gives 90 degrees.